Hello, I'm Michal from the Faculty of Informatics at Masaryk University, and this is a presentation of our paper titled Soft Alignment Objectives for Robust Adaptation of Language Generation, presented at the Annual ACL meeting in Toronto. A common approach in training generative language models is to maximize the likelihood of generating the correct reference token. This is achieved by minimizing a cross-entropy in predicting the next token of the reference given an input text X and previous tokens of the reference Y, also referred to as teacher forcing. We refer to this objective as maximum likelihood estimation, or MLE. A domain adaptation in language generation can mitigate specific imperfections of general models, such as avoidance of domain-specific vocabulary, and allows the model to improve on adapted domain also through the lens of generative metrics. However, the adaptation commonly comes for a price of model's generalization loss on other domain. While the model improves on the adapted domain, it continuously degrades on other non-adapted domains. This phenomena is also referred to as catastrophic forgetting. We hypothesize that catastrophic forgetting could be attributed to somewhat naive assumption of commonly used MLE objective, which is that only a single reference prediction is the correct one. We suspect that penalizing model in semantically correct predictions might foster its overconfidence on in-domain texts and diverge from correctly modeling the natural ambiguity of the generation problem. We formulate this hypothesis into our main research question and investigate whether the relaxation of single truth assumption might bring benefits to distributional robustness of generative models. Thus, we propose two main objectives that replace single truth targets with a distribution. This distribution respects semantic similarity of predictions to the reference. In a consequence, the target distribution assigns similar mass to all semantically similar tokens in the space of prediction candidate. We implement this approach in our first main objective that we call token align, which is the simplest possible reimplementation of MLE that uses semantic distribution as target. Token align computes the quality of each candidate target token as its minimal embedding distance to some token in the reference. Our second main objective, sequence align, extends this approach by removing the teacher forcing and samples the prefixes of the model from the trained model. Further, it replaces the loss formulation from cross-entropy to absolute distance loss, as we empirically find that this makes the resulting model more robust. In our experiments, we focus on the scenarios that can most benefit from more robust adaptation of language generation. These are low-resource machine translation cases where we adapt to low-resource or very specific domains, such as medical or law. We use models pre-trained on a mixture of opus domains and use multilingual BERT to obtain semantic representations of tokens. In our result, we report the rich adaptation quality on in-distribution and robustness on out-of-distribution domains. Our initial experiments already showed larger stability of align objectives on out-of-distribution evaluation compared to MLE. At the same time, we see that in-domain evaluations reach comparable gains. The results over 6 adaptation domains and language pairs show that alignment-based objectives are indeed very effective in persisting robustness of the original model, while LoRa, a recent parameter-efficient method, is the most competitive baseline in out-of-distribution robustness. It loses to align objectives, particularly on in-domain adaptation quality. On in-domain quality, the most competitive baseline is still classic MLE, but we see that align objectives reach comparable in-domain gains, with even larger improvements on semantic BERT score metric. In our further analysis, we take a look at specific features of adapting generative language models. First, we investigate if there is a connection between teacher forcing, or using prefixes of the reference in training, and catastrophic forgetting. We speculate that teacher forcing might magnify the catastrophic forgetting, as the domain of prefixes of out-of-domain that the model has to use diverges far from the in-distribution references. Second, we take a look at the impact of quality caused by decontextualization of token embeddings. Third, we measure the impact of the loss formulation that motivates the changes of sequence-aligned cross-entropy loss for absolute distance. We implement 3 new instances of sequence-aligned objective that help us to empirically assess these questions. SRAND is a dummy version of sequence-aligned, including self-sampled hypothesis, but with random targets instead of the semantically constructed ones. Sequence-aligned DEC is an instance of sequence-aligned using decontextualized embeddings that are needed in token-align. Sequence-aligned CE is an instance of sequence-aligned with cross-entropy loss instead of the absolute distance loss. As our main objectives, we collect the results over all evaluation cases, which are 6 in-domain trainings and 30 out-of-domain evaluations. We average the results and include the intervals, including all the evaluations. First, we see that sole exposure of the model to self-generated prefixes mitigate large portion of catastrophic forgetting of MLE. This supports our assumption that teacher forcing is also responsible for a portion of forgetting in adaptation. Second, we see that decontextualization does affect the quality of the model, but there is not a large drop in both evaluations as one might expect. We can see a drop in out-of-domain model robustness, but even with decontextualized embeddings, the resulting models are much more robust than MLE models. Third, while we see that cross-entropy delivers comparable in-domain quality, it significantly degrades out-of-domain performance. This motivates the reformulation of our loss in our main sequence-aligned objective to the distance-based loss. We note that this might be the reason why most of the previous work on sequential objectives, including reinforcement learning, use distance-based formulations. Thank you for watching. Please find further details in the paper, and we'd be happy to hear from you. So please don't hesitate to get in touch if your research interests align with ours.